Hello everybody and welcome to the Tiny Fibre Studio. My name's Bex and this is a channel all about knitting and spinning and lots of other crafty business. A lot of the videos that I do on this channel are kind of aimed at slightly more experienced spinners, people looking to experience different techniques or different types of fibre, but this is part of a series for beginner spinners. And in this video, I'm going to be talking about specific parts of spinning wheels and how a spinning wheel works. The reason that that's important is because when you do start spinning on a wheel, you will get lots of different bits of advice about changing your tension and, checking that there's no fibre trapped around the shaft of the flyer, and if you don't know what those terms mean, it can be really difficult to follow people's instructions. So thought it might be helpful to point out the different bits of a spinning wheel and how it works. I'm going to be using these two spinning wheels as examples of how manual wheels work. This style of wheel is called a castle style wheel, and that just means that this big wheel here, which is called the drive wheel, we'll come on to that later, is underneath this flyer section. Whereas on a Saxony style wheel, like this one, the drive wheel is to the side of the flyer assembly. So whether you have a castle style wheel or a Saxony style wheel, you'll see that actually they basically both do the same thing. If you don't have either of them, then I do have a video coming very soon about how to choose your first spinning wheel. I'm going to use the castle style wheel as the main example. I'll show you all the different parts on there, show you how it works, and then I'm going to come back to the Saxony wheel. So I'm going to focus on this one for the moment. At the end of the video, I'll also talk about the way that electric spinning wheels work, which is based on exactly the same principles. All three of the wheels that I'm going to show you today are set up in single drive Scotch tension. I'll look a little bit more in depth at the other two systems in another video. The basic premise of spinning on a wheel is that the spinner feeds a piece of untwisted fibre towards the wheel. The wheel then adds the twist and it stores the spun yarn on the bobbin. When the uninitiated look at a spinning wheel, they assume that the biggest part of the wheel is the bit that does the most work. But the large wheel here actually has comparatively little to do with it. So let's start at the bottom of the wheel and we'll work our way up. At the bottom of the wheel are the treadles. Some wheels just have one treadle, this wheel has two. The treadles are connected to these two bars called footmen. On this wheel, that's at the back of the wheel, but on some wheels the footmen are at the front. The footmen connect to the crank that goes through the drive wheel. So as I move my feet up and down, the drive wheel goes round. Around the drive wheel is a band called the drive band, which is usually made of cotton or alternatively a stretchy material. The drive band goes around the drive wheel and then up and over this section called the whirl or the pulley. On some wheels the whirl is on the front of the flyer, but on this one it's on the back. As the whirl goes round, so does the flyer, which is this U-shaped piece here. Whirls have grooves in them. The smaller the groove, the faster the flyer rotates. That rotation of the flyer is what puts twist into the yarn. Now that we've added our twist, the yarn goes in through the orifice, which on this wheel is this little hole. It travels around a couple of hooks and then onto the bobbin. On other wheels, the orifice might look a little bit different. It could be a hook, could be a coil, or a V-shaped piece of metal called a delta orifice. Those more open orifice designs are particularly useful if you're spinning thicker yarns or art yarns. If a wheel was designed to run with a cotton drive band, there will usually be a way to adjust the drive band tension to how taut that drive band is. On this one, it's this knob at the top, which moves the back of the flyer up and down. So we've got our twist going into our yarn by the flyer rotating, but we also need to store our spun yarn by getting it onto the bobbin. Otherwise, we'd just be putting twist into the same section of yarn over and over again. For the yarn to go onto the bobbin has to be travelling at a different speed from the flyer. There are different ways to do this, which I'll go through in another video, but the way that this wheel is set up at the moment is called Scotch tension. That's a very common way of making the bobbin travel at a different speed from the flyer. In Scotch tension, there's a second band called a brake band, which goes over the end of the bobbin and slows it down, allowing the yarn to get pulled onto the bobbin. We need to be able to adjust how strongly the yarn is being pulled onto the bobbin. So on every Scotch tension wheel, there will be a way to change how tight the brake band is over the top of the bobbin. On this wheel, it's a screw controlled by this little knob here, and that pulls on a spring which is attached to the brake band. Not every wheel will have a spring, but that is quite common. Remember, this is how Scotch tension works. If a wheel is set up in Irish tension, then the drive band would go over the bobbin and the brake band would go over the whirl. And in double drive, you'd have two loops of the drive band, one going over the whirl, one going over the bobbin. To look a little bit more closely at the flyer assembly, we're going to take it apart. The way this works is a little bit different on each wheel, with some of the components in different places, sometimes removable, sometimes not. On this wheel, I remove the flyer by opening a quick release lever, which allows me to move this piece at the front, which is called the front maiden. I move that out of the way, remove the drive band and the brake band, and then I can remove the flyer assembly from the rear maiden, and that's the flyer assembly detached. This bar here that holds the front and the rear maiden is called the mother of all. Not all whirls are removable, but on this wheel they are, so I can take the whirl off and that allows me to remove the bobbin. Now we're just left with the flyer itself. The metal section here is the shaft, and these are the arms with all the hooks in them to allow you to distribute the yarn evenly along the bobbin as it's being stored. On some wheels, the arms have sliding O-rings instead. Those are called sliding hook flyers. To put it back on, I place the bobbin and the whirl back on the flyer shaft, put the brake band back on the bobbin and the drive band back on the whirl. Then I place the end of the flyer shaft into the bearing, this hole here in the rear maiden. Then I bring the front maiden back into position and put the orifice end of the shaft into the front bearing. A bearing is where a rotating part like the flyer is supported. Most commonly on a spinning wheel they'll be made of metal, plastic or leather. Unless the flyer has a very large orifice, like some of the alternative options that we've mentioned before, you're probably going to use an orifice hook to feed the yarn through from the bobbin and out through the orifice. And those orifice hooks are going to vary from one wheel to another. This is the little selection that I use for my 3 wheels. So that's how the castle style wheel works. Let's have a look at the Saxony style wheel. When I press the treadle, just 1 this time rather than 2, it moves the footman. But this time the footman is made of cord and leather. The footman's still connected to the crank, which turns the drive wheel. The drive wheel moves the drive band. This one is a stretchy band. The drive band turns the whirl, and that in turn rotates the flyer. There's still a brake band over the end of the bobbin, and there's still a screw or a knob to adjust the brake tension. There's also still a screw to adjust the drive band tension. This one tilts the whole mother of all back and forth. And in this case, the front and rear maidens and the mother of all are all made of one piece of wood. On an electric wheel, the drive wheel is replaced by a motor. So all you really see is the mother of all, the maidens and the flyer assembly. On this eSpinner, the motor drives this little black wheel here, which is connected by the stretchy drive band to the whirl. And this time the whirl is at the front rather than at the back. It doesn't need more than 1 groove in the whirl because the speed is controlled by a dial. There's still a brake band which goes over the end of the bobbin, and there's a brake tension knob here to adjust how slack or tight that brake tension is. This eSpinner is currently using a flyer called a woolly winder. It has a little interesting trick up its sleeve because it's a sliding hook flyer, but the hook actually moves on its own. So it's got the ability to automatically distribute your yarn up and down the bobbin instead of you having to move your yarn along the hooks. It's generally an optional accessory for modern spinning wheels. So it's not necessarily something that you'll find on every wheel, but you might come across them, and I thought it would be fun to show you. So that's a comparison of 3 different wheels, all of them set up in Scotch tension. I'll look at Irish tension and double drive in another video. Those are different methods of getting the bobbin to spin at a different speed from the flyer. So there you go, that is how a spinning wheel works and all the different parts of a spinning wheel. If you found this video useful, I would really appreciate it if you would give it a like, a comment, and please feel free to hit the subscribe button. If you want to be notified of any new videos that I put up, just make sure that you press the little bell icon next to subscribe and you'll get notifications when I post a new video. So I hope this was useful. Thank you so much for watching, and I will see you again soon. Take care.